Welcome viewers. In this video we will see the details about the encoders in the digital electronics. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic encoder. An encoder is a digital circuit that performs the inverse operation of a decoder. So we see what is encoder, what is decoder. An encoder is a 2 to the power n input lines and n output lines. 2 to the power n inputs and n outputs. In case of decoder means n input lines and 2 to the power n output lines. Both are inverse. The encoder, in encoder the output line generate the binary codes corresponding to the input value. Based on the input value, the binary codes are generated as a output. The diagram shows the general structure of the encoder circuit. As shown in the diagram, the decoded information is presented as 2 to the power n input producing the possible outputs. Now we'll see the block diagram. So this is the block diagram of the encoder. 2 to the power n inputs, n outputs. So these are the possible 2 to the power n input lines. 2 to the power n input line. This is a possible n data output lines. This is a enable input. If the enable is 1, the decoder is enabled. It will give the output based on the input. If enable is 0, it is disabled. It will not produce any output. In order to enable or disable, we are having enable input. Now we'll see the one example. 2 to the power n inputs and n outputs. Let us consider n equal to 2. So 2 to the power 2 is to 2. That is 4 is to 2. That means 4 inputs and 2 outputs. 2 digits. 4 digit input and 2 digit output. How it is producing? So this 2 digit output is based on the input. Let us consider the inputs y3, y2, y1, y0, 4 digits. Then the output a1, a0, right? So we know that this 2 digits mean there are 4 possibilities: 0, 0, 0, 1, 1, 0, 1, 1. So these are all the 4 possibilities. We know that 2 digit, 2 to the power 2, 4 possible outputs are there. Now we'll see how we are getting these 4 possible outputs. For the first case, if y0 is 1 and other digits are 0, then we'll get the 0, 0 as the output. If y1 is 1, other digits are 0, then we'll get the next possible output 0, 1. If y2 is 1, other digits are 0, we'll get the next possible 1, 0. If y3 is 1, other digits are 0, then we'll get the fourth possible output 1, 1, right? So the value of y0, y1, y2, y3 will decide the 4 different possible outputs, right? y0 is 1, other terms 0 means we got 0, 0. y1 is 1, other terms are 0 means 0, 1. y2 is 1, other terms are 0 means 1, 0. y3 is 1, other terms are 0 means 1, 1. So we are getting all 4 possible outputs, 2 digits, so 4 possible outputs based on this 4 values: y0, y1, y2 and y3. So from this we can develop the logical expression that can be implemented with the logic gate. For example, these two are 1. For a1, these two. What is this? y2 and y3 is higher. So a1 is nothing but y2 plus y3. y2 plus y3 mean we need one OR gate. y2 and y3 will be added, so that we'll get the a1 output. For a0, these two are 1s, second and fourth. What is the corresponding input here? y1. For this one, it is y3. So we need to add y1 and y3. y1 plus y3. So we need one more OR gate. By connecting y1 and y3, we'll get the output a0, right? So logical expression for this is y2 plus y3. Here y1 plus y3. That can be implemented with the OR gate, so that we'll get the required output, 2 digit output. So So in this video we discuss the details about the encoder, 2 to the power n inputs with n outputs. Now we discuss with one example also. If n equal to 2, there are 4 inputs and 2 possible output, that also verified. And we discuss how to develop the logical expression and how to implement the logical diagram also. More videos available about the encoders. The details are given in the description box. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the 4 to 2 encoder. Details about the 4 to 2 encoder. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic 4 to 2 encoder. We know that encoder is a device having 2 to the power n inputs and n outputs. This is the basic structure of the encoder. 2 to the power n input, from that we can produce the n number of outputs. Here n is 2, so 2 to the power 2 is to 2, that is 4 is to 2. 4 inputs, from that we can able to produce the 2 outputs, right? So this 4 to 2 encoder consists of 4 inputs. Let us consider the 4 input y3, y2, y1 and y0. The 2 outputs are a1 and a0. So from the value of these 4 inputs, these 2 outputs are produced. Now we'll see how these 2 outputs are produced from the 4 inputs. At any time, only one of these 4 input can be 1, right? So only out of these 4, any one out of these 4 inputs, only one input will be 1. Other values are 0. So that we can get the respective binary code at the output. Among these 4 inputs, any one digit only 1. Other digits are 0. So based on that we can get the 2 different outputs. The diagram shows the logic symbol of the 4 to 2 encoder. Now we'll see the logic diagram. We'll see the block diagram of the 4 to 2 encoder. So this 4 to 2 encoder, 4 inputs, y0, y1, y2 and y3, and 2 outputs, a0 and a1. Now we'll see how it will produce the 4 different, if from 4 different inputs 2 outputs are produced. We'll refer the truth table. So the inputs are given, MSB y3, y2, y1 and y0. The outputs a1 and a0. See, this first we have y0 is 1, other terms are 0. We already discussed any one digit only 1. See this, any one digit only 1, other digits are 0. Suppose if y0 is 1, we'll get the output as a 0 0. We know that 2 digits are there in 4 combinations, 0 0 0 1 1 0 1 1, right? 2 digit mean 2 to the power 2, 4 combinations are there. So y0 is 1 means other terms are 0 mean we'll get the output as 0 0. If y1 is 1, other terms are 0 mean we'll get the output as 0 1. y2 is 1, other digits are 0 mean we got the output 1 0. y3 is 1, other digits are 0 mean got 1 1, right? So this y0, y1, y2, y3, any one digit only 1. Based on that we got the respective output, these 4 combination. y0 1 means 0 0, y1 1 means 0 1, y2 1 means 1 0, y3 1 means 1 1, right? Now we have the block diagram, then truth table. Now we need to go for the logic diagram in order to produce these 2 outputs from these 4 outputs, a0 and a1, right? So that we'll see the logical expression. We need to find the logical expression. We can implement this logical expression with the logic gates, right? For a1, there are these 2 are zeros, only these 2 ones are available. These 2 1 means this y2 is high level 1. For this one, y3 is high level, right? y2 and y3 is high for these 2 input. These two outputs are 0, right? So for these two outputs, what we have y2 and y3. So that a1 equal to y3 plus y2. Because of simple only 4 outputs, we are directly writing the equation. Otherwise, we need to go for Karnaugh map, K map, right? So these two are high level, these two outputs, the corresponding inputs are y2 and y3. For A0, these two are high level. For this one, this correspondingly what we have y1. For this one, we have y3. So y3 plus y1 is the logical expression for output A0, right? Block diagram, truth table. From truth table, based on the value 1, we got the logical expression y3 plus y2, y3 plus y1. Based on that, we can go for the logic diagram. The above two Boolean function A1 and A0 can be implemented using two inputs OR gate. Here plus is there, y3 plus y2. So added together. So we need one OR gate with two inputs. Here also we need one more OR gate to add y3 and y1. So we are having two OR gates, right? Here y3 and y2 is given. So these two will be added. We got the value A1. For this OR gate, we connected y1 and y3. So that we got A0, right? So this based on the logical expression, the logical gates are connected, the corresponding inputs are connected, so we'll get the corresponding output A1 and A0. So in this video we discussed the 4 to 2 encoder. Encoder means 2 to the power n is to n output. Here n is 2, so 2 to the power 2 is to 2, that is 4 is to 2. 4 inputs and 2 outputs. We discussed the logic, we discussed the block diagram, then truth table. Based on the truth table, we developed the logical expression. Then logical expression is implemented in the logical gates. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the 8 to 3 encoder, also called octal to binary encoder. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic 8 to 3 encoder. Because of 8, it is given as octal to binary encoder. We know that the encoder is nothing but a device with 2 to the power n inputs and n outputs, right? The input is 2 to the power n, the output will be n. This is the basic structure of the encoder. Here n is 3, so 2 to the power 3 is to 3, that is 8 is to 3, right? We are having 8 different inputs. From that we can get the 3 different outputs. That's why it is called a 8 to 3 encoder, also called as, because of 8, octal to binary encoder. So the 8 inputs, let us consider the 8 input y7, y6, y5, y4, y3, y2, y1 and y0. These are all the 8 inputs. The 3 outputs are A2, A1 and A0. So based on the value of these 8 inputs, we can get the 3 different outputs. 3 digits available in the output means we know that 2 to the power 3, there are 8 possibilities will be there, 0, 0, 0, 0, 0, 1, like that. 8 combination we will get based on the 8 inputs. Each input line corresponds to the each octal digit and 3 outputs generated corresponding to binary code. So that it is called a octal to binary code. Because of 8 inputs, it is represent octal digit. Because of 3 output, it is represent binary code. The diagram shows the logical symbol of octal to binary encoder. Now we'll see how we are getting the 3 different output from the 8 different inputs. Now we'll refer the block diagram. First we'll refer the block diagram. So this is the 8 to 3. This is not here 3 to 8. It is 8 to 3 encoder. 8 to 3 encoder. The 8 different inputs are available starting from y0 to y7 and 3 outputs A0, A1, A2, right? Now we'll see how we are getting these 3 different output from the 8 different inputs. So this is the truth table is available. The inputs are y7 to y0, then outputs A2, A1 and A0. We already discussed 3 digits mean 2 to the power 3, 8 combination will be there. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1. Right? First 4, the third digit is 0. We have 0, 0, 0, 1, 1, 0, 1, 1 like that. Right? Then how we are getting this? If y naught is 1, all other digits are 0, we'll get the first combination 0, 0, 0. If y1 is 1, other digits are 0, second combination 0, 0, 1. y2 is 1, then other digits are 0 mean we'll get the third combination 0, 1, 0. y3 is 1, then other digits are 0, fourth combination 0, 1, 1. Then y4 is 1, other digits are 0 mean fifth combination 1, 0, 0. y5 is 1, other digits are 0 mean sixth combination 1, 0, 1. y6 is 1, other digits are 0 means seventh combination 1, 1, 0. If y7 is 1, other digits are 0 mean eighth combination 1, 1, 1, 1, triple 1, right? So based on the value of y0 to y7, we are getting 8 different outputs. y0, y1, y0 1 means other terms are 0. If y0 is 1, first combination, y1 is 1, second combination. Like that we are getting 8 different combinations, right? This is the truth table of the 8 to 3 encoder. Now we have block diagram, then we discuss the truth table. Now we can develop the logical expression for A2, A1 and A0. Then that logical expression can be implemented with logic gates in order to get the 3 outputs. Now we'll see the logical expression for these 3. See, first we'll refer A2. These 4 digits are 1, right? First 4 digits are 0. What is this 4 digit mean? y4, y5, y6 and y7. These are all high level. So we can add y4, y5, y6 and y7, right? y0 to y3 we got 0 output. So no need to add. Only these 4 outputs are 1, that is corresponding from y4 to y7. So y4, y5, y6, y7 are added for logical expression A2. Then A1, first 2 is 0, second 2, next 2 is 1, that is corresponding to y2 and y3. So it is connected y2, it is added y2 and y3. Next 2 also 0. Then another next 2 is 1, that is y6 and y7. So y6 and y7 is added, right? y2, y3, y6, y7 are added in order to get the logical expression A1. For A0, see that first is 0, 1, 0, 1, 0, 1 like that. It is alternatively we got zeros and ones. So this one refers y1, this one refers y3, this one refers y5, this one refers y7, that is y1, y3, y5, y and y7, right? y0, y2, y4, y6 are zeros, so no need to add. Alternately we are adding 1, 3, 5, 7, right? So now we got the logical expression for these 3 outputs A2, A1 and A0 based on the truth table. So this is nothing but now we need to implement with the logic gates. What is this expression? All are added together, y7, y6, y5. So we need a OR gate. We need one OR gate for A2, one more OR gate for A1, one more OR gate for A0. So this totally we need 3 different OR gates in order to implement this logical expression. Now based on this we'll see the logic gates, logical diagram, how to implement this 3 with the logical diagram. So this is the logic diagram. We are having 3 different OR gates are available. OR gate means it will add, right? So here the input lines are available. y0 is not, y0 is not available, right? So that we are not drawn y0. y1, y2, y3, y4, y5, y6 and y7. 7 inputs are available. y0 is not available in any of the logical expressions, so that not drawn. So first we will see the A2. A2 means y4, y5, y6 and y7. Right. y4, y5, y6 and y7 are connected together. So that we got this logical output added. All are because of OR gate, all are added together. For A1, it is connected Y7, Y6, then Y3, Y2, right? Y7, Y6, Y3, Y2 are connected, so that we got this logical output for A1. For A0, alternatively, Y7, Y5, Y3 and Y1. These four inputs are connected together, so we are getting the corresponding output, right? So we got A2, A1, A0 as a 3-digit output with 8 combination. So automatically based on this value, we'll got the output. For example, Y7 is 1, we'll got the output. Y6 is 1, we got the output. Y5 is 1 or Y4. Because of OR gate, any one input is high, we'll got the high output. Similarly here also, right? So in this video, we discussed 8 to 3 encoder, also called octal to binary encoder, because of 8 input and 3 output. We discussed the block diagram, truth table, logical expression, then logical expression is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see 16 to 4 encoder, also called as decimal to BCD encoder. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. 16 to 4 encoder, decimal to BCD encoder. We know that encoder is nothing but 2 to the power n inputs with n number of outputs. That is the basic structure of the encoder. 2 to the power n inputs and n outputs. Here n is nothing but 4. 2 to the power 4 is to 4. 2 to the power 4, 16. 16 is to 4. 16 inputs and 4 different outputs. Because of 4 different outputs is called a BCD encoder, binary coded decimal. We know that binary coded decimal means 4 digits. Here we are produced here this decoder, this encoder produce 4 different 4 digits outputs, so that it's also called a BCD encoder. Here 16 inputs are there, so that is called a decimal to BCD encoder. The decimal to binary encoder usually consists of 10 input lines. Here 16 inputs lines available, but 0 to 9 only valid BCD. From 10 onwards we have 2 different digits. So here we consider only 10 inputs, 0 to 9. 11, 12, 13 means different. That is a different format for BCD. And 4 output lines. So 10 input lines, 4 output lines, then only it will be a BCD encoder. 10, 11, 12 different. So Y9 to Y0 is the inputs. A3, A2, A1, A0 is the output. 4 different digits of output. Each input line corresponds to the decimal digit and 4 output correspond to the BCD code. Right? So the input line, every input line is each decimal digit, differ by decimal digit. Accordingly, 4 output BCD codes are generated. Right. This encoder accept the decoded decimal data as a input and encode it is to the BCD output, which is available on the output lines. The diagram shows the logic symbol of the decimal to BCD encoder. Now we'll see the block diagram. So this is the 16 to 4 encoder or decimal to BCD encoder. Y0, Y1, Y2, Y3, Y4, 5, 6, Y7, Y8, Y9. There are 10 different inputs are available. These, according to these 10 different inputs, we have 4 different outputs: A0, A1, A2 and A3. So at a given time, any one digit will be 1. For example, Y0 will be 1, other terms are 0. Then we'll get 0, 0, 0 as the output. Then Y1 will be 1, other terms are 0, we'll get 0, 0, 0, 1. Like that, we'll get 16 combination. Here only we are using 10 inputs, we are not using 16 inputs, right? 0 to 9, 10 inputs. So then only we'll get the valid BCD as a output. Now we'll see the truth table, how the 10 inputs are converted into 4 digit outputs. Now we'll see the truth table. So in this truth table, the inputs, there are 10 different inputs, Y0 to Y9, 10 different inputs are available. and 4 digit outputs A0, A1, A2, A3, right? Suppose if Y0 is 1, all other inputs are 0 means we'll get 0, 0, 0. Y1 is 1, other digits are 0 means we'll get 0, 0, 0, 1. We know that this is the consecutive digits 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0 like that. Suppose Y2 is 1, remaining digits are 0 means we'll get 0, 0, 1, 0. If Y3 is 1, remaining digits are 0 means we'll get 0, 0, 1, 1. Right? So this is nothing but these 4 are 0, these two digits 0, 0, 0, 1, 1, 0, 1, 1. Then here 0, 1. Next to 4 combination 0, 1, again 0, 0, 0, 1, 1, 0, 1, 1. Like that it will repeats. Right. Suppose Y4 is 1, other digits are 0 means 0, 1, 0, 0. Then Y5 is 1, other digits are 0 means 0, 1, 0, 1. Y6 is 1, other digits are 0 means 0, 1, 1, 0. Then Y7 is 1, other digits are 0 means 0, 1, 1, 1. So this is first 4 set of output, this is next 4 set of output. Suppose Y8 is 1, then it becomes 1, 0, 0, 0. Y9 is 1, it becomes 1, 0, 0, 1. Right? So this is nothing but here we know that 16 combination of if the 4 digits are there, we'll have the 16 combination. In that we are having only 10 combination here. 0, 0, 0, 1, 1, 0. Again here 0, 0, 0, 1, 1, 0, 1, 1 is repeated. Right. Now we have the valid 10 different BCD codes are available. Now we need to find the logical expression for this outputs A0, A1, A2 and A3. First we will see the A3. Right. So in that A3, so these two are high level. 1 is available, logical 1. All other terms are 0. This 1 means is correspondingly Y8 is 1, for this Y9 is 1. So that Y9 plus Y8. All other terms are 0. Right. So this is the logical expression for A3. Then we will go to A2. A2 here, these are all zeros. These 4 are 1s are available. 1, 1. These 4 outputs are 1, again it is 0. So we'll see the corresponding what is the input here, Y4, Y5, Y6 and Y7. These 4 are, when these 4 are high, we got the high output, logically high. Right? So Y4, Y5, Y6 and Y7. These are all added. This is the logical expression for A2. Then we'll go for A1. A1, see here, these two are high level. And again two things, two low level, again two high levels. So we'll see correspondingly here Y2 and Y3. Y2 and Y3. Here Y6 and Y7. So Y2, Y3, Y6, Y7. These are all added together. Other terms are 0. So this is a logical expression for A1. Then we'll go for A0, A0. This is first 0, 1. Alternatively we have zeros and ones. That is Y1, then Y3, Y5, Y7 and Y9. Alternatively we are getting the high level. So it is added Y1, Y3, Y5, Y7 and Y9. Right. Now we have the truth table. From the truth table the logical expressions are framed. Now we need to implement this logical expression with the logic gates. Right. There are 4 different outputs are available. So this is nothing but Y9 plus Y8 means we need a OR gate. We need to add these two values. Right. So here also for all 4 outputs we need a OR gate. 4 different OR gates are needed. The corresponding inputs we need to connect. Now we'll go to the logical diagram. See here the 4 different outputs are available, A0, A1, A2 and A3. So all possible inputs are available here, Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8 and Y9. So according to the requirement we can connect. Right. For A3 what we need is Y9 plus Y8. Right. So only Y9 and Y8 is connected. So here what we'll get, Y9 plus Y8 because of OR gate. For A2 what we need, Y7, Y6, Y5 and Y4. These 4 terminals are connected. Other terminals are not connected. So we'll get the output A2 as a output. For A1 it is Y7, Y6, then Y3, Y2. Right? 2, 3, 6, 7 inputs are connected, so that we will get A1. For A0 alternatively, Y9, Y7, Y5, Y3 and Y1. These are all the inputs connected, so that we will get the A0 output. So this A0, A1, A2, A3 is the 4-digit binary coded decimal with a 10 combination, 0 to 9, 10 combination. 10 to 15 we are not considered, that become an invalid BCD code, so that we consider only 10 inputs. So in this video we discuss the 16 to 4 encoder, that is decimal to BCD encoder. We discuss block diagram, truth table. From truth table we design the logical expression, then logical expression is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the details about priority encoder. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic priority encoder. We know that encoder is a device will having 2 to the power n inputs and n output. 2 to the power n input with n number of outputs. In this we will see what is the priority encoder. The priority encoder is an encoder circuit that include the priority function. Out of 2 to the power inputs, the priority will be given. The output will be based on the priority of the input. The priority encoder, if 2 or more inputs are equal to 1 at the same time, the input having highest priority will take the proceedings, right? If more than 1 digits are 1, the highest priority will be taken into account. Now we'll refer the truth table, so we are able to understand. So this is there are 4 inputs available, 4 digits and 2-digit output is available. So because of 4 inputs we have 16 combination. Here 4 combinations, right? And also one more output is available, verification. This verification used for whether any all are 0 or any one is available. If all are 0, the circuit will not produce any output because no priority. So this V also 0. At least one is there, then only this stamp verification will be higher. Otherwise, if all are 0, the output of the circuit is nothing. It will not produce any output. So to verify if all are 0 or at least any one is available, we are using the term V. Now we'll see the truth table. So the highest priority is given for D3. If D3 is 1, whatever may be D2, D1 and D0, it will give the output as 1, 1, right? The D3 is 1, whatever may be the remaining digits, will get the output as 1, 1. The second priority goes to D2, but D3 should be 0. D2 is 1 and D3 is 0 as the second priority. Whatever may be D1 and D0, it will give 1, 0. Right. Third priority goes to D1. If D1 is 1, D2 and D3 should be 0. Then it will give the output 0, 1. The last priority is D0. D0 is 1. D1, D2, D3 is 0. It will give 0, 0. There is nothing. 0, 0 is no output. Right. So highest priority given to D3. If D3 is 1, we will get 1, 1. If D2 is 1 but D3 is 0, we will get 1, 0. If D2 is 1, D1 is 1 and D2, D3 is 0, we will get 0, 1. If D0 is 1, other terms are 0, we will get 0, 0. So in all these cases, a minimum 1 is available. So the verification output is 1. Now we'll see the description. Table shows D3 input with highest priority and D0 input with lowest priority. When D3's input is high, regardless of the other inputs, the output will be 1, 1. If the D3 is 1, we will not bother about other remaining terms, we will get the output as 1, 1. Similarly, we have the other description. The D2 has the next priority. If D3 is 0 and D2 is 1, regardless of the other lowest priority, the input will be 1, 0. Two things. D2 should be 1, at the same time D3 should be 0. Then only we'll get 1 0. Similarly, the output for D1 is generated only if the highest priorities are 0. That is D2 and D3 is 0, D1 is 1, we'll get the output as 0 1. Right. So the verification, the output V, valid output indicator, indicates one or more inputs are equal to 1. If any one or two inputs are 1, it will be give the 1 as a output. If all are 0, it will give 0 output. So that we can verify at least any 1 is available at the input. Right. Now we'll see the detailed truth table. So here 4 digits available, 16 combinations are there. Here we simply marked as XXX. The X may be 0 or 1. This X may be 0 or 1. Now we'll see the detailed truth table, that is 4 digits, 16. 16 possible inputs and 2 possible outputs. Now we'll see the detailed truth table. So this is the detailed truth table. D0, D1, D2, D3, 0, 0, 0. Like this we'll have 16 possible inputs are available. 1, 1, 1. Finally we have 1, 1, 1. There are 16 possibilities available. For that case we need to check the output. Right. So first we will see the highest priority. Highest priority is D3. Right. D3. If D3 is 1, whatever may be, we will get 1, 1 as the output. Here also D3 is 1, 1, 1 as the output. Here D3 is 1, 1, 1 as the output. Here also 1, 1, 1 as the output. And here also 1, 1, 1 as the output. Here also 1, 1, 1 as the output. Whatever may be the remaining digits. Then this 1, 1, 1 as the output. Here 1, 1 as the output. So wherever we have D3 equal to 1 indicated by this red color line, we got the output as 1, 1. We no need to check the remaining terms. Right. Next priority is D2. We need to check the D2. This D2. D2 should be 1, but D3 should be 0. That is 1, 0. This is D2 should be 1. This should be 0. In that case, the output will be 1, 0. Here it is there. Here 0, 0. But here 0, 1. It's not applicable. Here 1, 0. D2 is 0 and D2 is 1, D2 is 0. So we'll got the output as 1, 0. But here D2 is 1, but D3 is already 1. This is already completed. This. Now these two. Here 1 and 0. So we'll got the output as 1, 0. These two not applicable. Then another 2 available. This 1, 0. So that we'll get 1, 0. Then here 1, 0, 1, 0. Right? So wherever D2 is 1, D3 is 0, we got the output as 1, 0. Then the next priority is D1. We need to see that D1 should be 1, but D2 and D3 should be 0. Then we'll got the output as 0, 1. So here it is applicable. But here not applicable. Here 1 is there. Not applicable. Here's 1. Is not applicable. There these two are 1. So only this combination will get 0, 1. This is already covered in first priority. This is already covered in second priority. This is all covered in first priority. So we'll have only this combination will give 0, 1. Similarly, another 4 terms available. D1 is here 1. But here it is correctly there. D1 is 0. D0, D2 and D3 is 0. D1 is 1. So we'll got 0, 1 as the output. These are all not possible. It's already covered. Right. The last one is D0 should be 1. D0 should be 1. So first 8 D0 is 0. Remaining 8 D0 is 1. Right. Here 1 all are zeros. So for that case we'll get 0, 0 as the output. Right. So this one 1, 0, 0, but here 1 is there. Already covered. This is also already covered. These are all already covered. So only this combination will get the last priority 0, 0. Already all are 0, 0 mean the output also 0, 0. Right. So this will give the detailed truth table. Now we'll see again one by one. See all are 0 means 0, 0. D3 1, 1, 1. D2 1, 1, 0. Here both are 1. So already this is covered. You will check only D3, 1, 1. Here D1 is 1, remaining 0. So 0, 1. Like that we'll have. Now we need to go for the logical expression for y1 and y0. By using K-map, we need to find the logical expression for y1 and y0. Also the valid indicator V. For these three outputs, we need to find the logical expression using the K-map. Now we'll go to the K-map. So based on the truth table, first we will find the K-map for y1. Here the inputs D0, D1, D2, D3. So 4 variable K-map. These inputs are framed. From the table it is marked. This one is X. 0, 0, 0. Both are 0, 0 means it will not produce any output. That is indicated by the input valid indicator. These three are 0 and these are all 1. You can refer the truth table. From the truth table it is marked. So we can group these 8 cells red color and these 8 cells green color. Right. While grouping all these 8 cells, these corresponding inputs are cancelled. Only we have to refer 0, 1 and 1, 1. This 0 and 1 will be cancelled. Only 1 is there. 1 means D3. We'll get a D3. While combining these 8 cells, the corresponding rows will be cancelled. Only we have to refer the third column and fourth column. 1, 1, 1, 0. This 1 and 0 will be cancelled. Only this will be 1. This will 1 means D2. Right? So D2 plus D3 is the expression for Y1. So this is based on the K-map. The video for K-map available separately. We can refer that. Now the K-map for Y0. D0, D1, D2, D3 inputs. These 8 variable K-maps are framed. We know that this first condition is 0. All are 0 means don't care condition. The remaining inputs are marked as 1 from the truth table. So there is two combination. We can group these 8 cells, red color, and we can group these 4 cells. Right. While grouping these 4 cells, we have to refer corresponding second row and third row. 0, 1, 1, 1. This 0 and 1 will be cancelled. Only this 1 will be available. This 1 means D1. This D1 is there. We have to refer the corresponding first column and second column. 0, 0, 0, 1. This 0 and 1 will be cancelled. Only this 0 will be there. 0 means D2 dash. D2 dash. Right? D1, D2 dash is the grouping of these 4 cells. While grouping these 8 cells, these corresponding rows will be cancelled. 0, 0 cancelled by 1, 1. 0, 1 cancelled by 1, 0. So the second column and third column we have to refer. 0, 1, 1, 1. This 0 and 1 will be cancelled. Only this 1 is there. This 1 means D3. So Y0 is D3 plus D1 D2 dash. Right. So we got the expression for Y1 and Y0. Now we'll go for the verification. Input valid indicator. So D0, D1, D2, D3 inputs. These are all marked. We know that this case 0, 0, 0, 0 means no output. For all other cases minimum 1, 1 is there. So all are 1. Right? Only this is 0. So we can group. This is one grouping. Green color. Red color another grouping. This is one more grouping. This is one more grouping. So where there are 4 groupings available with 8 cells. So by simplifying we got D0 plus D1 plus D2 plus D3. We will verify one by one. First we will take the green color. This green color means corresponding rows are cancelled. Only you have to reverse second column and third column. 0, 1, 1, 1. This 0 and 1 will be cancelled. This 1 will be there. This 1 means D3. Now this red color. All rows will be cancelled. You have to refer third column and fourth column. 1, 1, 1, 0. So this 1 and 0 will be cancelled. Only this 1 is there. This 1 means D2. D2 is there. Now these 8 cells. These 8 cells mean the corresponding columns are cancelled. Only you have to refer second row and third row. 0, 1, 1, 1. This 0 and 1 will be cancelled. Only this 1 is there. This 1 means D1. Now verify these 8 columns. The corresponding columns will be eliminated. You have to refer third row and fourth row. 1, 1, 1, 0. This 1 and 0 will be cancelled. Only this 1 is there. This 1 means D0. So D0 plus D1 plus D2 plus D3. Now we got the expression for Y1, Y0 and V. That can be now implemented with the logic gates. Right. Now we'll see the logic gates. So these are all the required inputs D3, D2, D1 and D0. By tapping is taken and a NOT gate is connected, so that here we'll get the D3 dash. Similarly, D2 tapping is taken, connected to NOT gate, will get D2 dash. D1 and D0 is connected. D1 dash, D0 dash is not required, so that NOT gate is not connected. So we have 8 inputs are available: D3, D2, D1, D0, D3 dash, D2 dash. Right. First we will see Y0. What is Y0? Y0 is nothing but D3 plus D1, D2 dash. Right. So here we need one OR gate. OR gate is available. One input is D3. So D3 is connected. Another input is D1 into D2. Further we need one more AND gate. So D1 is connected, D2 dash is connected. So here we will get D1, D2 dash. Here D3 available. Now these two are added together. D3 plus D1, D2 dash. So we will get the output as Y. What is Y1? Y1 is nothing but D2 plus D3. So we need one OR gate. D2 and D3 is connected. So this is added. So we'll get the Y1 as a output. So Y0, Y1 is our required output. And one more output is verification. Verification V. What is the V? It is D0 plus D1 plus D2 plus D3. These 4 inputs are added together by the OR gate. So this is D0, D1, D2, D3. 4 inputs are given, 4 are added together. So it will give the verification output. So in this video we discuss the priority encoder. Encoder is the 2 to the power n input and n output, n possible output. In that the priority is given based on the priority, which one having highest priority, which one having lowest priority. Accordingly the output is generated. Here if D3 is the highest priority, if D3 is 1, then it will generate only 1 as the output. D2 is 1, but D3 is 0, means it will generate 1 0. D1 is 1, D2 and D3 is 0, means it will generate 0 1. If D0 is 0, means it will generate 0 0. Based on that we have the truth table. Then we discuss the detailed truth table. From the truth table using K-map we got the logical expression. Then the logical expression is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.